Section 2.8 on density. So what's more dense, a pound of feathers or a pound of lead? Well, a pound of lead is the same weight as a pound of feathers, but what do you know about the volume? A pound of lead would be a small volume, but a pound of feathers would be a large volume. So suddenly both of those are involved in density. Density is going to be the mass, how much something contains, how much material is in it, how much matter is there, divided by how much space it takes up. So the smaller amount of space that a mass takes up, it's denser. The density is based on cramming more stuff in the same box. So if you make the box bigger, but you keep the mass the same, you've reduced its density. Okay, if you hot air rises, by the way, for that reason. Hot air expands, and that means the same amount of air that was in a small space is now in a bigger space. And since a bigger space is less dense things float above more dense things. Denser things sink, and less dense things rise. That's exactly what's going on. Density is excellent way of making some ideas of what's going on when chemicals combine with each other. And that's what we're looking at this year. So density is the definition of density is mass divided by volume. So whatever the mass units are, it doesn't matter. Whatever the volume units are, it doesn't matter. Those units would be part of your answer. So if you're using grams and milliliters, then your density is grams over milliliters. If you're using grams over cubic centimeters, then your density is grams over cubic centimeters. Okay, and remember that by definition, 1 milliliter equals 1 cubic centimeter. So you can use that as a conversion factor later. Okay, so density. If you remember that less dense things float over more dense things. So even things like North America, which you think of as very, very heavy, why doesn't North America sink into the middle of the earth? Well, if you have various layers of different densities, whatever's denser sinks, whatever's less dense rises. The crust, even though it's made out of rocks, and you think of rocks as heavy, if that heaviness is in a bigger box, then it will float. Okay, if you think of water and you think of wood, and wood is less dense than water, the molecules of water are more packed together and wood are more open up. There's air spaces in wood, less material, bigger volume, then that means wood will float on water. Anything will float on anything as long as it's less dense than the thing it's floating on. Okay, so here ice is less dense than water. That's why ice floats on water. It's a very unusual substance because as you freeze things, they usually become denser. Water, because of the shape of the molecules, configure themselves with big open spaces. And those open spaces take up more room. And since it takes up more room, ice, solid water, this is ice, floats on liquid water, which is water, okay, based upon its density. Osmium is a very dense metal. What is its density in grams over cubic centimeters if 50 grams has a volume of 2.24 cubic centimeters? Well, grams is on top, centimeters cubed is on the bottom, so you take 50 grams on the top divided by 2.22 centimeters cubed, and you divide those two numbers, 50 divided by 2.22. And that's how you answer, whatever that would be. Don't know. Is it 22.5? That would be what I guess. So, volume by displacement. A lot of times if you have a very weird shape, you can't do a math problem to figure out its volume. If I have a box, I can do that. Length times width times height will give me the volume. But if I have a rock that's very unusual, or I have some kind of a weird shape, I can use water to do it. So I put a graduated cylinder that has markings along the sides. I put a certain amount of water in it so that I can read where it is. Then I put the small object in that graduated cylinder, and the water goes up. Wherever the material is, the water can't be, so the water has to sit on top, and that increase in volume is the volume of the material. The same volume of water would be the same volume of, the volume doesn't change. It's the same volume of water would be the same volume of this cylinder, whatever object that they put in it. So whatever it went up, that's the volume of your object. That's one way of figuring density. You need to know its volume. Mass would be easy, you just measure it. You just put it on a scale. Put a scale, measure it, find out its grams, how many grams, then put it in some water, find out how much the water goes up, that's its volume, mass divided by volume. This is easy peasy, okay? So 9.5 was what we found out, was 9.5 milliliters, and a milliliter equals a cubic centimeter, so we know that. And then you weigh it out, it weighs 68.6 grams. Divide those two, you'll end up with a density of 7.2 grams per cubic centimeter. And then as you do that, you're comparing one density to another. Every material has a different density depending on its mass and volume. Okay, so what do? What's the density of a 48 grams of a metal when you put it in the graduated cylinder, rises up to a certain point? Okay, let's just figure out how to do this. From 25 to 33, okay, you're going to subtract that, and that's your volume. And then your grams is going to go on top. Mass divided by volume. So 48 divided by that difference will give you the answer. I don't have my calculator here. We would do it. But it's very simple, and we'll do these in class. I hope that makes sense. I don't want to cheat you, but I can't write, at the moment, I can't write on my screen. Okay. All right, so we find 33 minus 25 is 8. So 48 divided by 8, I could have done that in my head. 48 divided by 8 is 6, so 6 grams. Okay. And now sink or float simply means if it's less dense, it floats on something more dense. So if it's less dense than water, such as a cork, it floats on top of the water. You have other things that float in the water and other things that sink to the bottom of the water. Okay, that's based upon its density. Denser things sink, less dense things rise. So you can actually look at different materials, even though they're all liquids, if they have different densities, they'll sit on top of each other. You know that oil is less dense than water, it sits on top of the water. Okay, your salad dressing all separates in the refrigerator. That's what's happening. One's less dense, one's more dense. If you were to put water on top of honey, the honey would sink to the bottom and the water would sit on top of it because the honey is denser than the water. And you could do this with all types of materials, oils and alcohols and waters and different things. And you could even put things that would float inside these layers. Pretty good. This is called a density column. Okay, so how do you do it? We want to find out how much it weighs, and we want to know how much its density or how much its volume is, and then divide those two factors. Density of octane is 0.702. What's its mass of 875 mils? Okay, so you would say X kilograms divided by 875 mils equals 0.702 grams. There's a trick there. I don't have kilograms and kilograms. I have grams on one side and kilograms on another. That means I would have to do it to grams first and then convert to kilograms. I'd have to say mass or grams over 875 mils equals 0.702. Okay, solve for X by multiplying 875 by 0.702. Find out how many grams that is. And then go grams, 1,000 grams in a kilogram, and then divide by 1,000 to get this. Okay. Try as you can, and then we'll do a lot of these in class. Okay, so that's what they're doing here. Olive oil has a density of 0.92 grams per milliliter. How many liters? All right, you see, you've given in milliliters how many liters of olive oil are in so many grams. So you would have to say 285 grams over how many milliliters equals 0.92. Find out how many milliliters, and then multiply by 1,000 to find out how many liters that is. All right. I hope that is making some sense. That's the end of chapter 2, which is not easy because you haven't seen it before, but this is very kind of crucial because all of the other chapters are going to be building on these concepts. So we'll try, as you don't understand, that's when you ask questions, and we'll do it in class together. All right.